So we've picked three numbers, 4, 6, and 8. The red number is going to indicate our base. So our base is going to be 4, 4. The exponent is going to be 6 and 8. And what we're going to do is we're going to look at how we multiply powers that have the same base. In order to do this and to make it make a little bit of sense, we're actually going to take each of the powers, starting with 4 to the exponent 6, and write them all out in expanded form. So 4 to the exponent 6 means 4 times 4 times 4 times 4 times 4 times 4. In other words, 4 multiplied by itself, how many times?
6.
Correct. And then we're going to take 4, we're going to take 4 to the exponent 8 and do the same thing beside it. So 4 times 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 4. How many 4s did I just write out? 8. And then what I'm going to ask us to do is ask us this question of you. And that question is, including the black 4s and the red 4s, how many 4s are there all together?
14.
14. So when we had 4 to the exponent 6 times 4 to the exponent 8, and we get 4 to the exponent 14, what do we do with those exponents in order to go from 6, 8, and get 14? What do you think? If you don't know, we'll do it again. We'll try with other numbers. All right, let's try it again. So this time, instead of 4, 6, and 8, give me another number from, let's say, 1 to 9. 5? Let's make the numbers a little smaller. Give me numbers from 1 to 6. Go.
2.
2? And the next number, another one?
3.
What's that?
3.
Sweet. Good. All right. So this time our base is 5. Our base is 5, and our exponents are 2 and 3. Okay. Easy enough. Now, we're going to write out our first batch of 5s. How many 5s do we write out for the first batch of 5s?
2.
Good. 5 times 5. How many batches of 5s do we write out for a second batches of 5s?
3.
5 times 5 times 5. How many 5s are there all together, black and red?
5.
So it's 5 to the exponent 5. So what we want to ask ourselves is, what do we do with 2 and 3 to get 5? And what's the answer?
Added.
We add them. Correct. Does that work for 6, 8, and 14?
Yeah.
It does. So when we are multiplying exponents that have the same base, you add the exponents. Okay? So in general, if you have something like x to the exponent a times x to the exponent b, you add the exponents, x to the exponent a plus b. So whenever we multiply exponents that have the same base, you add the exponents. Okay? Same thing here, except we're dividing. So I'm going to get you to give me 3 numbers. Give me a number, give me any number, 1 to 9.
10.
Sure.
4.
10's fine. Give me 2 numbers, 1 to 6.
4.
And
7.
2. 7 would have been fine, but 2's even better. Okay. So what this is going to mean is we're going to take 10 as our base, and we're going to make sure the big number comes first. The big number here is 4. So it's 10 to the 4 divided by 10 squared. We can write division as a fraction. So that means we're going to write 10 to the exponent 4 divided by 10 to the exponent 2. And then we are going to expand it. So 10 to the exponent 4 means 10 times 10 times 10 times 10. And 10 to the exponent 2 just means 10 times 10. Now, when we are dividing, and this is something that I'm actually doing with my grade 11s at the moment, when we're dividing, and you have a whole bunch of stuff being multiplied on top, and a whole bunch of stuff being multiplied on the bottom, if you see the same thing on top and bottom, they divide out to give you 1. So you could divide a 10 and a 10, and you could divide another 10 and a 10, and they give you 1s. So let's do that. We have no 10s left on top. Sorry, on bottom. How many 10s do we have left on top? How many? We have 2 10s, right? 2 10s left over. So it's going to be 10 to the exponent 2. What do you think we did with the exponents to get 2 as an answer?
Subtraction.
Correct. You subtract them. So when you're dividing powers that have the same base, you subtract the exponents. So if you have 10, oopsies, let's just say x to the exponent a divided by x to the exponent b, you go ahead and subtract their exponents. And that's what you do. But both of these rules that we've learned require the powers to have the same base. The powers have to have the same base, but so long as they do, if you're dividing, it's the same as subtracting the exponents. Okay, here we go. We're going to do some examples here. The first example says to write each expression as a power. That means we leave our answers as a power. 8 to the exponent 5 times 8 to the exponent 9. What do we do with the exponents? So we get 8 to the exponent.
14.
Very good. 5 plus 9 is 14. Second question. Negative 2 to the 7 divided by negative 2 to the 4. What do we do with the exponents? Subtract them. So I'm actually going to take another step to do this. 7 minus 4. And maybe what I'll also do then is do the same thing here. I'm just doing this so that if you look back at this later, it'll be crystal clear what this came from. 5 plus 9 is 14. All right, now going back to this one, 7 minus 4. What's 7 minus 4? 3. So we get negative 2 to the exponent 3. Both of these questions told us to write the expression as a power. That's why we don't write it as an answer. We figure it out as a power, and that's all we do. In the next two examples, they specifically tell us to evaluate, which means we'll do exactly what we just did. And then we'll find out what the answer is by putting it into standard form. So the first question is 3 to the exponent 4 times 3 to the exponent 3. Using our exponent laws, what do we do with those exponents? Add them. So that's 4 plus 3, which is 3 to the exponent 7. And now, because it says evaluate, we're going to take our calculator and we're going to figure out what 3 to the exponent 7 is. What's 3 to the exponent 7?
343.
Nope, not to 7. That's 3 to the exponent 5. 2,187. Okay, so when it says evaluate, we have to simplify using our exponent laws first, and then evaluate. We're going to do the same thing for the second question here. We're going to focus in on these two first. What operation is between those first two powers? What's the operation between them? Because it's division, that's right. So we're going to take away those exponents. Now, if we want, because these are all to the same power, we can also look at the times 2 to the exponent 8. What do we do with exponents when we're multiplying and they have the same base? We add them. So we can add 8 to this. So it's going to be 5 minus 4 plus 8, which is 2 to the power 9. And what is 2 to the power 9? Or 2 to the exponent 9, rather. 512. That's very good. And that's how we do that question. The next two questions are similar. We're going to simplify first and then evaluate. So, we don't know what to do when we add two powers, so we're not going to do that. But even so, division comes first with order of operations. So when we divide, we do what with the exponents? When we divide, we do what with the exponents, rather? We subtract. So we're going to go 7 minus 5. And that's going to be what? 4 to the exponent 2. Like I said, there's no exponent rule for adding. So actually what we have to do at this point is just evaluate. We have to evaluate what 4 cubed is. We have to evaluate what 4 squared is. And then we add those numbers together. What is 4 cubed?
32.
What's that?
32.
Not 32. 64. Very good. And what's 4 squared? 16. And now that we've figured out both of those powers in standard form, we'll add them together. 64 and 16 add up to 80. So if you get a question like this on your quiz tomorrow, or in your homework for that matter, you see that I've got 4 lines of work there. you should have 4 lines of work there too, or a minimum 3. So the answer is 80. We've got one more question to do. This one. Now, with this question, because there's brackets, we're going to do this first. What's the operation inside the brackets? So we do what with the exponents? Right. So it's going to be, just a second here. There's no operation between this and this. So think of there as a multiplication symbol. So it's going to be 2 to the exponent of 5 times, and we do what with those exponents inside the square bracket? Subtract them, so that's 9 minus 7. And then we have minus 2 to the exponent 6. What is 9 minus 7? 2, very good. And now we have 2 things going on, multiplying and subtracting. What comes first? Multiplying. When you multiply, you do what with exponents? You add them. So it's going to be 2 to the 5 plus 2. 5 plus 2 is? Now, do not be tempted. Do not be tempted to say, well, 2 to the exponent 7 minus 2 to the exponent 6, that's 2 to the exponent 1. No, it's not. Remember what I said. There's no exponent rule when we're adding or subtracting powers. What we actually have to do is figure out 2 to the exponent 7, figure out 2 to the exponent 6, and then subtract them. So what's 2 to the exponent 7? Very good. And 2 to the exponent 6 is 64. When we subtract those, what do we get? Beautiful. And that is it.